Hello and welcome to Transfer Switch FAQ videos. Today we will be discussing of the benefits of using a deadband timer. There are many basic features that are included in automatic transfer switching equipment nowadays. One of the main features of an ATSE is the possibility to set different values on timers. Timer setting can greatly impact the way your product behaves in your installation. Let's take for example the deadband timer. This parameter is present in even the most basic ATSE on the market. So what is a deadband timer? S1 or S2 deadband timer actually defines the minimum electric dead time or blackout time to respect when the source is lost or when transferring between sources. This defines the minimum load supply downtime so as to allow residual voltages that may be generated by inductive loads such as motors to decay. How does the timer work? In the last Transfer Switch FAQ videos, we have seen how the fail and return timer works for an ATSE or a controller product. Well, an ODT timer or deadband timer is actually placed in between the fail and return timer, or in some products it can also start at the same moment the fail timer starts to count. In the first case, when the priority power supply has failed and is considered not available by a product, the fail timer will start to count. When the fail timer is over, the ATSE changes over to the intermediate zero position. Once it reaches the zero position, this is when the deadband timer starts to count. Its purpose is to leave enough time for inductive loads not to have residual voltage in between its terminals. Once the deadband timer has finished counting, the product will then be able to transfer to the emergency power supply. In some products, the deadband timer will actually start counting at the same moment the fail timer starts. This is because since the priority power source is considered not available, and if the voltage is below 50 VAC, it can be seen as a zero position with no voltage present. Once the deadband timer has finished counting, the product will also be able to transfer to the emergency power supply. Note that a deadband timer can be shorter or longer than the source failure timer. In order to set the correct value for your deadband timer, you need to properly understand how your downstream load works and if residual voltage might be present during the priority source failure. It is easier to think that by setting a 0 second on a deadband timer, you'll be able to perform a faster overall power source transfer. Well, this is not entirely true. In the long run, there are many risks that can appear when not letting enough time for residual voltage to decay. For example, residual voltages on inductive or motor loads can be transferred to non-synchronized power source, which can result in damage to sensitive loads. Transferring from one power source to another, if residual voltage is still present, can also result in overload protection triggering, which will decrease your protection device's lifespan. This is why setting your deadband timer correctly is one of the many ways you can use to ensure your installation's overall reliability and efficiency. Thank you for watching our Transfer Switch FAQ videos. If you have any questions, don't hesitate to contact your Socomec representative. Bye-bye!